All right, so we are on our brand new Unit 5. Unit 5 is all about system of linear equations. Today's date is Wednesday, November 20th, 2019. So 5-1, system of equations with graphing. Who wants to read the objective? Quiet raised hand. Yes, Esha.
Um, Test solutions to equations and solve a system of equations with graphing.
There it is. So we're going to be learning 3 different ways of solving a system of linear equations. And I can list them for you really quickly if you would like. The 3 ways that you will know by the end of this unit how to solve. The first one is by graphing. So we're covering that one today. The second one is by, I don't know the order, but I'm just going to randomly choose substitution. And the third one is called elimination. You will be, well, I'm hoping you're going to be near a master at all 3 of these methods. So we're going over the first of those today, solving them with graphing. But before we even talk about how to solve them, I need to talk about what they are. So a solution, and this is going all the way back to Unit 1, I think, or maybe Unit 2. A solution, what is a solution to an equation? It's the number that can be plugged into both sides of the equations, or I guess the equation, I should scribble out the S, to both sides of the equation, where both sides of the equal sign are the what? You know you're a solution if I plug in like 1 and 1, and then I boil it down, I do some math. The left side and the right side, what happens, Charles?
They're the same.
They're the same, exactly. It's basically saying 1 equals 1, or 3 is equal to 3. If the left side and the right side are the same number, that means you have a solution when I plug it in. But that was only for one equation. Charles has already identified what a system of equations is, and that's more, right? So let's talk about what that is. A system of equations is blank or more equations. That's the only definition. What?
2 or more.
There it is. 2 or more equations. So in my class, I'm only going to be giving you 2 to start out with. Once you hit Algebra 2 and Calculus and stuff like that, I'm going to be doing 3 and higher. It gets really, really hard the more and more I add, so 2 is a good starting point. And then a solution to a system of equations. So notice the difference. Solution to an equation versus solution to a system of equations. Now I have multiple equations. So a solution to a system of equations is a number that is a solution to, anyone want to take a guess here? Charles?
Many or multiple?
You're really, really close. If I have 2 or more equations, what's a word that can say 2? Starting with a B, do you know it?
Oh, you B. I know.
By.
Oh,
Bio.
You can call them Y if you want, or you can keep guessing.
Yeah, why?
both.
It is indeed both of the 2 equations. We'll give it to both of them, yeah, because he attempted. So that's the key thing here. I'm going to be giving you 2 equations. Chunk, chunk. You're going to be plugging in a number, x and y, and see if the left side is equal to the right side on both equations. If it's a solution to one equation but not the other, it's not a solution to the system, while it is a solution to just one. We're testing the entire system. All right, let's give this a shot. We have example number 1. Again, the x coordinate here is 1, so write an x above that. The y coordinate is 2. It always goes x, then y. X is first, y is second. All right, so let's go ahead and rewrite this. I'll do a little arrow to indicate I'm going to go ahead and rewrite this equation. This is now going to be 2 times what? Quiet raised hand. Larissa?
1.
2 times 1, perfect. Because, again, 1 is the x coordinate. Plus what? Quiet raised hand. Easy XP. Esha.
2.
2. There it is. And I always put parentheses around it when I substitute because it's just good form, especially when I might need to multiply. And that should be equal to 4. So let's do some quick math. This is some mental math. Everyone's going to shout this one out. 2 times 1.
2.
2 plus 2.
4.
Left side and the right side seem to be the same, so we can give a giant check mark. That worked. So those are considered procedures when everyone shouts them out. So we can do 2 procedures worth, so I think that's 20 XP to the entire class. All right, let's try rewriting. Yeah, it's 10 XP at the very top-ish for a procedure. Yes, please. All right, so now we're going to go ahead and substitute in again. This is going to be 3 times what? Quiet raised hand. 3 times what with a quiet raised hand? Kira.
2.
3 times 2. Dang it. I was hoping you guys would be tricked by that. Yes, so most people always say, oh, well, it's the first number, or the first variable, so I'm going to plug in 1. No, this is the y variable. Y matches with 2. Darn, and most of you guys probably wouldn't be tricked by that. You guys are too smart. All right, let's keep going. This is going to be substituting in what quiet raised hand? Jade?
1.
It is indeed 1 plus 1. All right, let's do some more mental math. Here we go. Okay. 3 times 2.
6.
1 plus 1.
2. Not
No.
6 does not equal 2. So you can do a little X to say, nope, that didn't work.
Wait, who did the first one here?
Yeah, Kira did the first one. So now let's answer the question. Is 1 comma 2 a solution to the system? Is there a quiet raised hand that could do this one? Is 1 comma 2 a solution to the system? Let's actually answer the question. Amen.
It is not a solution to the system.
It is not. Thank you. Because it only satisfied one of the equations.
I think it's on the chair.
All right. So what I want you guys to do right now is on your own, practice the math, learn the math on your own. Here we go. Example number 2, give it a shot. All right, so we're back. I need one entire volunteer to do all of the first equation. Is there anyone that has a card still?
I used my card first.
Charles and Wyatt have already participated twice. I'm going to give it to Kira.
Okay, I didn't know I could do that.
So 5 times 5 minus 8 equals 6 times 3 minus 1. So 5 times 5 is 25 minus 8 equals 17.
Okay, so the left-hand side was 17.
And 6 times 3 is 18 minus 1 equals 17. So that works.
Perfect. And then we'll give it to someone else. Yeah, thank you.
Card.
No, sorry, I saw Ulysses first.
Okay, so I put in 3 for x, which is 4 times 3 plus 3 equals 3 times 5. And then 4 times 3 is 12, plus 3 is 15. And then 3 times 5 is 15.
And you concluded it is or is, okay, yes, all right. And then final volunteer, is 3 comma 5 a solution to the system? Emma?
Yes.
It is indeed yes. All right, so that homework assignment is going to be pretty easy. It seems like most of you are getting that. Let's just do a quick fist of 5. How well can you do that first half of the objective testing solutions to system of equations? I just see 5s all around. Very nice. All right, let's go on to graphing review. So mini spiel about mathematics. If you know Algebra 1 really well, you're going to have an easier time in geometry. You're going to have an easier time in all the other math classes because math builds on itself. So all of our laptops should also be shut for this lesson. So math builds on itself, so that means if you ever don't understand something, you really need to go back and learn that because chances are you're going to need it in your next math class. I can't tell you how many times I'm pulling out my hair because I'm in Algebra 2 and people don't know how to solve just a normal equation. So make sure you really understand what's going on in this lesson. For example, you need to know how to graph slope, intercept form, and standard form from last unit in order to be successful on this unit. So is there anyone that can give me the general form for slope intercept form? Does anyone have their card?
Pencil.
Charles.
Why was that not supposed to be?
Perfect. Ooh, let's try the harder one. What's the general form of standard form?
The what?
The general form meaning like you have entirely variables. What does standard form look like?
I don't know.
Anyone have their card? Oh yeah, Larissa.
Wait, is it y1 minus y? Or y2 minus y1?
So you're thinking of point slope form, which is really good that you memorized that, but that's not quite standard form. So you want to take another shot at standard form? It has a capital A to begin with.
Capital A?
Oh. Yeah.
Oh, delta. Wait, no, I don't know.
You can call it someone else.
Okay, is it ax plus by equals c?
It is indeed. I forgot the y there. By is equal to C. And again, A, B, and C are all integers. That means whole numbers. So I need another quiet raised hand. Can someone give me an example of slope-intercept form? What?
Y equals 2x plus 3.
Perfect. You guys can make your own example. You don't have to copy down why it's, but there it is. Y equals 2x plus 3. That is an example. If you see that form, you're like, oh, I'm going to do these steps on the left-hand side. And if you see this form on the right-hand side, you're going to do that one step. I mean, I've simplified it over time. Someone give an example of standard form, please. Eamon?
2x plus 3y equals 6.
That is a really, really good example because it will be easy to find x and y intercepts. I was hoping that you do something that is divisible by both 3 and 2, and 6 is divisible by 2 and 3. Yes, thank you, Eamon. That was an awesome example. Let's go ahead and talk about how to graph those things. So the first thing is you're going to graph the y-intercept. So the y-intercept, if you have forgotten, B, this guy right here is your y-intercept. I assume that you guys know that, which means you don't necessarily need to write that in your notes. And then from there, you're going to use slope to find the second point. And let's review slope again. What is the definition of slope? You can give either definition. We have a bunch of them. Let's talk to Kira first.
Rise over run.
Rise over 1. There's one definition. Someone give me another definition of slope.
Oh,
Jade.
delta y over delta. Oh,
Someone give me another definition of slope. Charles.
y1 minus y2 over x whole minus x.
Not the standard one, but it'll definitely work. Yeah, perfect. And then what were you going to say?
I was going to say, like, all of these is basically just a change in y above the change in x.
Yeah, exactly. And that's what delta y over delta x means, because delta means change. Perfect. So we all understand what slope is, so you can use one of these definitions to help you. And I will be doing an example on the very back side when I have one of those forms, so you can see how to do that. And then you guys are responsible for doing example number 4. So I do, you do. Let's talk about x and y intercepts. So the x-intercept, how do I find that? We've done it before, but what do I do in order to find the x-intercept? There's still some people that haven't turned in their cards, and we're getting low on questions. I want to see how many people can get in here.
VC's
No, you
No. How do you
how's y'all?
How's you?
Wyatt, go for it.
Okay, so to graph the x-intercept, you just need to make the y variable 0, so that cancels it out, and then you can solve for x.
Exactly, yeah. So set the y equal to 0, or if you want to put in notes, because this is kind of useful too, cancel out. It cancels out the whatever the y is. And therefore, how do I find the y-intercept with another quiet raised hand? Larissa?
You have to make x intercept 0.
Or yeah, just the x variable 0. Yeah, exactly. And it cancels out that x variable. Cancels the x. Perfect. So I'll be showing you an example on the backside, but make sure you know the procedure, make sure you know what those forms are. And Larissa did bring up that there is a third form that you're not talking about here, Mr. Sindel, and that's y1 or y minus y1 all over or equals, I can't speak, y minus y1 is equal to m times x minus x1. Why aren't we talking about this point slope form? And it's because it's not on the homework, so it's not worth reviewing, but that is another form that I could be giving you. These are the two forms that are on the homework. That's why I'm reviewing them. Let's move to example number 3. I am giving you 2 different forms. Normally on Khan Academy, they'll both give you both slope-intercept or both standard form. This one I'm mixing them up. That way we get some good practice. So we need to find the solution by graphing. What's up, Emma?
Teacher, you forgot the other. Did you forget the other bracket?
Other,
Like
oh, like over here?
Yeah.
Actually, the way that you write a system of equations is you only have a left bracket. And we'll be getting used to that over time. But yeah, it does look kind of weird, right? It only has the one on the left.
Yeah.
What's up? Yeah.
Example 4 looks like exactly the same as example 3, like the same equation.
Oh my gosh.
They're exactly the same.
Yeah.
Okay.
I thought you were gonna like maybe put a twist to it, but I was like,
That's exactly the same.
Oh my gosh. Okay. Well, I totally messed up there. I wonder if I can remember what exactly the equation was. We'll work on example 3 together, and I'll try to figure out what I did for example number 4. So example number 3, I have point slope form. Again, this looks like, not point slope, it's in slope intercept form. I have the slope, I have the intercept, it's all nice and aligned. So my first step is to, quiet, raise hand. First step is to graph which point? Emma. Careful there. You're going to graph the y-intercept. 3. Do I graph 3 on the x-intercept, or on the x or the y? Oh, 3 on the y. Okay, so I'm going to graph 0, 3. That was our first point. Thank you, Emma. And then from there, I'm going to have to do a little bit of math to figure out what my next point is. Charles, talk to me.
You go down 1 and the right 3.
It is indeed down 1, right 3. Again, the top number is how much up or down. So this can be up/down. You always assume, just for the sake of making the procedure easy, that the negative goes with the top number, and then the bottom number is always going to be right. You don't have to worry about right or left. It's always right as long as you're making the bottom number the positive. So I'm going to go down 1 because it's a negative 1, down 1, and then right 3, as Charles said. And I can keep doing that, right? Down 1, right 3, down 1, right 3. The more points you have, the merrier. The more accurate your graph will be. So I can also go left 3, up 1. Left 3, up 1. No, that's off the graph.
We need rulers to draw a line through this.
Rulers would definitely help. You guys want to grab rulers really quick? This is a good time. So as we make our line with our ruler that goes through all of those points, let me make the correct slope and I can move it in the right spot. So we have that line. Next, we need to graph 7x plus 6y is equal to 48. So the way that I do that is, I don't know, let's go look. Oh yeah, I find and graph the x and y intercepts. Ugo, tell me my first step.
You have to combine, or you have to cancel x.
Okay, yeah, so sub in 0 for x, so this all goes away, that 7x is gone, and I now have 6y is equal to 48. What do I do from there, Ugo?
Divide 6,
Divide both sides by 6, and I get y is equal to
7.
y is equal to 7. What does that mean, Ugo?
7 from the y.
Yeah, so the y-intercept is 7. Thank you, Ugo. What's up?
Is 48 divided by 6 7? I thought it was 8.
So it is 8. Yeah, catch the student error. Thank you for doing that. Y is equal to 8. Thank you, White. Thank you, Ugo. And then we are on to the x-intercept. Is there another quiet raised hand that can do that for us? How do I find the x-intercept after I found the y-intercept? Esha?
Well, you turn the y into 0, so then it would be 7x equals 48. And you divide by 7 on both sides,
Right.
it's not
May I help?
yeah,
Because 7 times 7 is equal to 49, it doesn't go in nicely, so maybe I'll just keep it at 48 sevenths.
Yeah, that's weird. I must have messed up on that problem. Huh. Yeah,
It'd be like
I was
6
expecting it to come out as 7, but that would have been 49 divided by 7. So 48 sevenths. Yeah, it's a bad problem. Sorry, guys. 48 sevenths is approximately equal to 7. Because again, 49 divided by 7 is 7. So this is approximately equal to 7. If we want to figure out what it is exactly, 48 divided by 7 is 6.857. So it's not even, that's a bad problem. I apologize. Let's assume that it was 7. And then go ahead and make a line between those 2 points.
That's it.
So what do you guys think the solution is to both of these equations? Again, and I will point this out before I talk about this. A solution to anything on this yellow line, this is a solution, this is a solution, this is a solution. There are an infinite number of solutions. This line is a physical representation of the solutions to this one equation. Meanwhile, this green line, every single point on this green line is a solution to this equation. Now, what's a solution to both of these equations?
Oh,
Is there a quiet raised hand that can tell me? Kira?
6, 1.
6 comma 1.
They converge.
It's wherever the lines cross. And again, the logic behind that is anything that is on a line is an answer. So where is a point that is on both lines? It's where the lines cross. And eventually we're going to be talking about, well, what happens if your lines never cross? Or what happens if your lines are the same line? Then they're crossing at an infinite number of answers.
And if they don't cross, then there is no solution.
Exactly, yeah. So that's the graphical way of doing that. And I've kind of stumbled upon the problem with doing these types of problems with graphing. Graphing, sometimes you get bad numbers, right? We have to come up with a different way of answering these that makes it so that it's exact. What if this point was actually not 6, 1? What if it was like 5.91, 1? Would we know from graphing?
No.
Unless you're really, really, really accurate or had a computer, right? You probably wouldn't know. So again, this was a bad problem, but theoretically our answer is 6, 1. The answer is x is equal to 6, y is equal to 1. So that was the answer. Please box it. 6, 1 is the answer. You have to have the coordinates there. And I want you guys to try the same thing, and I really, really hope that this problem comes out well, because otherwise we had 2 bad problems back to back.
Is that y equals 2/3 x minus 2?
Oh yeah, thank you for catching the error. It should be y equals 2/3 x minus 2. So our bracket looks like this. Y is equal to 2/3 x minus 2, and 2x plus y is equal to -10. Graph both of these lines. There should be a very clear answer, and if it's not, I apologize. All right, good luck.